So in this video, we treat all the relevant concepts we need to know about imaginary numbers and complex numbers. Sorry, this is imaginary and not imagery. So imaginary numbers and complex numbers. Okay, now this is one mistake that we usually do. We confuse the words, the two terms, imaginary numbers and complex numbers. Now, imaginary number is any number which consists of a combination of a real number and the imaginary number I. So where the imaginary number I acts like a coefficient, acts like a the variable, and then the real number aspect looks like the coefficient. So that's an imaginary number. So these are examples of imaginary numbers: 3i, negative 4i, root of 3i, 61i. So any real number combined with I, 3 over 2i, and it goes on and on. Now, complex numbers, on the other hand, is when you have a real number and then an imaginary number which are combined by either plus or minus. So for example, um, sorry, for example, when you have something like this, 3i or 3, sorry, 3 plus 4i, okay, 4i. Now this here will be a complex number and not an imaginary number because it's made up of what? A real number and an imaginary number combined by plus or minus. So another example would be root of 4 plus 3 over 2, 3 over 2i. This is also an imaginary, sorry, this is also a complex number. So I hope you now understand the difference between an imaginary number and a complex number. Now, the imaginary number comes as a result of the fact that we cannot find the square root of a negative number. Now, the square root of any negative number wouldn't give you any value, any real number. So it gives rise to what we call an imaginary number or the I. Now, from this, we can deduce that I squared will be equal to what? Negative 1. Okay. I squared is equal to negative 1 because when you square this, the square root goes. So you have I squared equals negative 1. Now we can use this to evaluate some higher powers of it. I. So I cubed will be I squared times I, which will be negative 1 times I, giving us negative I. Okay, negative I. And then I to the power 4. I to the power 4 will be I squared times I squared, which will be negative 1 times negative 1, giving us 1. Now, these, from here onwards, I to the power 5, the pattern repeats itself. So I to the power 5 will be the same as I to the power 1. It's the same as I to the power 1 or I. And I to the power 6 will be equal to I to the power 2. I to the power 7 will be equal to I to the power 3. And I to the power 8 will be the same as I to the power 4. Okay. So I to the power 6, I to the power 7, and I to the power 8. So due to this, we can use, what you have to know is the first three. Okay. What you have to know is these ones. I squared, I cubed, I to the power 4. And you can apply it to any power that any higher power of I in order to find it. And that's how you go about it. So let's say you are given I to the power x. Okay, you have I to the power x. Now that's what you do. You look for the closest multiple of 4 to x. Okay, so the closest multiple of 4 to x. So after finding the closest multiple, you now count from that closest multiple to x. So when you count, you should either get 1, like your count, the number of counts before you reach x. You should either get 1, 2, 3, or 3. Okay. Now, when depending on the number of counts, then it means that the power of I to that power would be equivalent to I to the power, the number of counts, the corresponding number of counts that you had. So let's take examples. So let's say you have I to the power 66. Okay, I to the power 66. Now what you do is find the closest multiple of 4, which is 64. Now you count from 64 to 66. Now from 64 to 66 is 2. You count 65, 66, which is 2. Now it means that I to the power 66 is equivalent to I to the power 2. Now, since you know your I to the power 2 to be -1, it means I to the power 66 is the same as I to the power, sorry, the same as -1. Let's take another example. I to the power 44. Now, I to the power 44 is an exact multiple of 4. So in that case, the count to that is 0. So it means it is the same as what? You know, I to the power 4 is the same as is 1. Okay. So since the count is exactly, if the power is exactly a multiple of 4, it means it is equivalent to I to the power 4. So in this case, I to the power 44 is the same as what? I to the power 4, which is equal to 1. Okay. Let's take a last example and we move. I exponent 103. Now, I exponent 103, an exact multiple of closest multiple of 4 is 100. 100 count down to 103 will be 3. So it's the same as what? I to the power 3. And we know I to the power 3 is negative I. So I to the power 103 is also equal to negative I. So that's it for here. Now we move to, sometimes you have fractions. You might be given questions where you have fractions, where the denominator, you have a complex number in the denominator. Now you would have to eliminate this complex number in the denominator before you proceed with your calculations. Now, that's how you go about it. Now, let's give an example. Let's say you have 3x all over 4. So, sorry, let's do it 3i. Okay, 3i. Let's do it 3i. So 3i all over 4 plus 2i. Okay. So now we want to eliminate. Now, before you proceed, you'd have to eliminate the imaginary number in the denominator here. That's what you are going to learn about. Now, what you do is that you multiply the denominator by its conjugate. So we have what we call the conjugate complex number. Now, the conjugate complex number is the same thing, but then you change the sign here to you negate the sign here, making it negative negative 2i, negative 2i, yes. So this is what you do. So you multiply it by 1, the same, you multiply by 1, but in this case, it will be 4 minus 2i, that's the conjugate here, all over another 4 minus 2i, okay? Another 4 minus 2i. Now this, you should also be able to identify this to be a perfect square. Okay, this is a perfect square. So you just know that your final computation would be 4 squared minus 2i squared. So this would be 4 squared. Like this would be equal to, in the denominator, you would have 4 squared, 4 squared minus 2i squared, which would be 4i squared. Okay, 4i squared. So this is what you have. Now you know your I squared is negative. Your I squared is what? Negative 1. So it means it will be 4 times negative 1, which will be positive 4. So it will be 4 squared plus 4. And you know 4 squared is 16 plus 4. 16 plus 4 is what? 20. So it means here we would have something like this. So you simplify the numerator aspect. So you have what? 12i. You have 12i. 12i minus 3i multiplying negative 2i will be negative 6i squared. So negative 6i squared, you know I squared is negative 1. So negative 6i squared becomes positive 6. Then all over 20. 20. Now this will be your answer. Now you can separate them. So you have 12i over 20. Simplify 12i over 20. 2 here, 6. 2 here, 10. Sorry, let's use 4. 4 here, 3. 4 here, 5. So 3 over 5. 3 over 5i. 3 over 5i plus. Then your 6 over 20 would be what? 2 goes here, 3, 2 goes here, 10. So 3 over 10. So this would be your final answer. Very simple. So to eliminate your sorry, to eliminate your complex number in the denominator, you multiply it by the conjugate, and then multiply the numerator also by the conjugate, and then you have this. And you have to be able to identify the perfect square below here to make your calculations easier. So that brings us to the end of the video of complex numbers and imaginary numbers. See you in the next video.